Hello, everyone. My name is Arfi. I've been working as a solution architect for security data ads. I have over 18 plus years of experience in data security and privacy space. And today I'm here for a session on AI-driven cybersecurity, intelligent threat detection, and privacy in the post-quantum era. Today we'll be discussing about the evolving cyber threat landscape, where we'll be understanding the current threats and the essential role of AI/ML for modern defense and building a AI/ML classification framework where we'll be architecting multimodal detection system and real-time pipeline for emerging threats and privacy preserving ML techniques and those how we can leverage that in AI/ML detections and implementation and operational excellence. We're transitioning AI/ML solution from proof of concepts to the production deployment and monitoring. And finally, preparing for post-quantum era, where we'll be using the future proofing of ML system against the challenges of post-quantum cybersecurity. Evolving cyber threat landscape. So we all know that the signature-based systems currently are not of capable or sophisticated to the attacks that we have. Now we have all modern ways of doing attacks are coming from different sources. So there are APTs employ increasingly sophisticated evasion techniques. There are zero-day explosives targeting previously unknown vulnerabilities, polymorphic malware, and fileless malware, and even in the supply chain attacks, compromised trusted software, distributed channels, and so all because of these advanced attacks, the conventional security tools struggle to keep up the pace, and they are failed by 38% detection today with the sophisticated attacks. And so there is a need for an enhancement where we use AI/ML cybersecurity to detect these ahead of the time. So what we do here is we first do the behavioral detection, and then we do the predictive capabilities, and then adaptive response and resource optimization. In the behavioral detection, we use AI/ML techniques excel to identify anonymous users and system behaviors and detect threats that signature-based tools are lack of. And then predictive capabilities, leveraging these threat intelligence ML algorithms can proactively forecast emerging threats before fully materialize. Means we leverage the threat intelligence and the AML algorithms have a predictive analysis to do and then predict it before it materialize. And then the adaptive response, ML systems continuously learn from the new data and enabling them to adapt defense against the attacks the vector autonomously. So resource optimization will do AI power triage significantly reduce by intellectual intelligently prioritize threats based on comprehensive scores and contextual analysis. And so where we know that how to respond, and then based on the priority and seniority, we use resources optimization while responding. And these advanced ML classification models drastically improve the cybersecurity outcomes, and that enables 93% detection rate from previously unseen signature-based tools that we have. And here we'll be using multimodal detection architecture where we first gather the data, we use supervised learning and deep learning here. And in the supervised learning, we utilize the labeled data sets of known threats for classification, where we'll be using random forest, gradient boosting, and support vector machines. And so in unsupervised learning, it identifies anomalies by detecting deviations from the normal patterns, where we'll be using isolation bias, one class SVP, DB scan, clustering it. And finally, the deep learning, where we apply neural networks for complex pattern recognition, where we'll be using LSTM networks, transform models, conventional networks. And these are the ensemble approach combines diverse models to achieve significant higher accuracy and reduce false positives compared to the individual model. So if we compare what's happening at the compared to the traditional way of data classification to the AML based is in the traditional classification, we use either a regular expression or a metadata patterns. But here, as the AML is evolving, we are using all these AI techniques to add more context and content to it, so that we'll be doing a more accurate data classification where we'll be seeing 80% of the accuracy without any efforts, and where we are minimizing the false positives at a greater rate, and then increasing the higher accuracy in the classification. And then feature engineering for cybersecurity ML, where we'll be using network traffic features and user behavior feature and host basic feature. Means in the network traffic features, we'll be studying the protocol deviation anomalies and the deviation flow metadata, where deviation volumes will be featured, and then temporal patterns and bursts and destination entropy and geolocation. And in the user behavioral feature, we'll be verifying that authentication patterns and how the users are authenticating, and access time distribution, at what time they are trying to access, and data access and the movement patterns, and where at what time they are running some queries or the command frequency profiles. And then host-based feature, we will process execution chain, system call sequences, resource utilization patterns, and registry and file system changes. So effective feature selection increases model performance by 40% when reducing the computational overhead. And real-time classification pipeline architecture. So this is very important here, the from where it starts and how we automate this process. The first step is data ingestion. We collect all the information from sensors, logs, and network tabs, and database logs and all. And then we feature extract, as we discussed in the real time. We real time parse it and vectorize the signals based on the data ingestion. And then we do ML and ML where parallel supervised and deep models will be used. And then based on that, we do the scoring. We'll use aggregated models to add the risk scores. And based on the risk scores, you automate the responses, you trigger mitigation or update training data. And then the where we can use the privacy preserving ML technique. So because you are processing a huge data as part of this, and there could be some sensitive data about the industry that you are working in. That's where we use these techniques to be in compliance and with the regulations like GDPR, HIPAA, PCI, PHI regulations, CCPA regulations. So we'll be using the federated learning and differential privacy and homomorphic encryption. Federated learning, it transforms the data into decentralized USs with the local data and eliminate the raw data exchange. Means the data is not going anywhere. It's all local to the model, and it processes it even with the sensitive data. Differential privacy is the same thing as federated, but where you'll be adding some noise to the trained data to put output of mathematical privacy guarantees, preserving utility. So in this case, it's the same raw data, but we'll be adding some noise to it so that it mimic the data and then use that huge data for ML processing it. And homomorphic encryption, where it enables computation on encrypted data without decryption AML operation, unsensitive data while maintaining confidentiality. Yeah, this is on the fly encryption it does, and without decoupling it, so that AML can use that data for their processing. And how we do the implementation. So from POCs to production, this is a phased approach where the first phase one is the foundation, phase two is the control deployment, and phase three is the scaled production. So in the phase one, what we do is we establish a robust data collection, as I mentioned, from different sources, and then we do the labeling as part of data classification and perform essential feature engineering and selection. And we conduct initial model training and validation and integrate this with the existing soft tools. And then in the control deployment, we deploy models in shadow mode against the existing systems. We measure performance rigorously against established baselines. We optimize threshold and minimize false positives using techniques, and provide comprehensive security team training and collect the feedback. And in phase two, it's a scale production. We gradually transition from legacy detection systems, implement CI/CD pipeline to continuously update the models and automate model retraining and deployment cycles, and finally integrate this dashboard with the real-time performance and visualization. This is a phased approach. The advantage is you reduce the risk while enabling continuous validation and improvement of ML systems. And then operationalize the excellence and monitor. And as part of operationalization, that for excellence, we see the performance indicators like we detect the latency, and average time to classify incoming traffic and false positive rates, then attack coverage and percentage of known attack vectors, zero-day detection success rate in identifying previously unseen threat. So this is a continuous improvement process where you automate these models to detections and take the human feedback and then threat intelligence integrated with that, and then you do A/B testing of model improvements. And next one is the preparing for the post-quantum cybersecurity. So post-quantum is the next generation, and how we were leveraging the post-quantum cybersecurity into this threat detection. And where here we'll be using quantum threat models, where the quantum computing, particularly algorithms like source, possesses a significant threat to current public key cryptography, including RSA, ECC, and Dale-Hellman. And then the post-quantum cryptography. NIST has identified post-quantum cryptography standards like crystal kyber, which is a key encapsulation, and dilithium digital signature to protect ML models against future quantum threats. So these are the prone the cryptographic techniques that the ML models are currently using. And then the strategic ML system preparedness, where key strategies for ML systems in the quantum transition involve integrating crypto agility, adopt hybrid classic and post-quantum approaches. So proactively, if we integrate post-quantum cybersecurity into ML pipelines is critical, because for the coming 5 to 6 years, the transition is projected. Our organization must be now ensure a long-term cybersecurity lesson. Our organization should be ready to adopt to these post-quantum cybersecurity embedded into the AML process. So key takeaways. So we covered AI/ML driven cybersecurity transformers, privacy first ML deployment, and how the phased approach and measured implementation, and then finally proactive quantum readiness. Thank you for your time. I hope you enjoy the session, and thanks a lot.